We have a new mirror design, better sight lines, better aerodynamics, better performance overall. On top of that, we added a drop glass. There's a lot of fixed infrastructure, whether it's gate operations or interacting with a port or a telecom. These will make drivers' lives easier.
Just a few weeks ago, the semi-assembly crew at Giga Nevada finalized assembly on the last 30 to first-generation Tesla semis. They are now being steadily delivered into the hands of Tesla's priority customers, while these early adopters are sharing positive feedback about their switch to using electric Class 8 trucks. Many have also noted that these Tesla semis still struggle in the cold and are primarily suited for short-haul urban routes. That is all set to change. Recently at the Tesla Semi factory, over 1,000 new staff, including engineers and technicians, have joined the production line. All are fully geared up to assemble the second-generation Tesla Semi, which will feature a brand new battery system, a reimagined headlight configuration, and 18 other radical upgrades developed by the Semi team over years of beta testing. These new Semi units are slated to launch in October, with a planned production volume of 50,000 vehicles annually during the ramp-up phase, which starts in late 2025 and runs through 2026. So, what will the Tesla Semi Gen 2 actually look like? And is its new sticker price justified by the design and capabilities it provides? Welcome to Tesla Car World. So, how does the new Tesla Semi Gen 2's price defy consumer expectations? Of all Tesla's electric vehicles, if one truly seems to challenge the laws of physics, it has to be the Tesla Semi. Ordinarily, a semi-truck that weighs as much as 80,000 pounds would be predicted to have poor performance. This is why electric trucks have been viewed with skepticism by industry experts for so long. The primary issue is rooted in the design. Electric trucks need huge, heavy batteries to handle the needs of long-haul freight shipping. Many have contended that batteries cannot deliver energy with enough efficiency for such demanding long-distance vehicles. However, Elon Musk was not shy in his counter-argument. He confidently stated that heavy-duty engines can indeed run on batteries for the first time ever. An electric truck can go up to 500 miles fully loaded and as far as 800 miles when empty, while saving as much as 1 million gallons of diesel fuel, which equates to around $3.5 million in operating expenses. This is why Elon Musk has consistently referred to the Semi as a money-making machine. The adoption of the Tesla Semi has not been without some reluctance. The steep price tag can be an obstacle for medium-sized carriers. Nevertheless, major corporations like PepsiCo, Walmart, and Cisco have already integrated the Semi into their pilot programs, attracted by its reliability and the potential for better driver retention. At the same time, the competition to expand charging infrastructure is intensifying. Tesla's megacharger network is at the forefront, with plans for 1.2 megawatt V4 stations and 46 public locations anticipated by 2027. This greatly outpaces third-party rivals and helps resolve charging worries for fleet managers. Meanwhile, traditional diesel truck manufacturers are also feeling the heat. Legacy OEMs such as Daimler and Volvo are fast-tracking their own electric truck programs, but none can currently rival Tesla's projected production volume or its vertical integration of batteries, power electronics, and charging networks. When Tesla originally revealed the Semi in November 2017, the company boldly set prices at $150,000 for the 300-mile model and $180,000 for the 500-mile version. The exclusive Founder Series had a $200,000 price, figures that undercut standard Class 8 diesel trucks, and generated buzz about an electric freight revolution. Those initial manufacturer suggested retail prices presented the Semi as both an ecological step forward and a wise financial decision, promising fleet managers fuel savings of 20 cents per mile and a significant lifetime cost benefit over diesel trucks. Fast forward 8 years, and though global inflation and battery advancements have altered the sticker price, they have also boosted performance, dependability, and long-run savings in ways few foresaw. Consider the recent Rider pilot program. They first intended to use 40 to semis but adjusted their order to 18 after seeing revised cost estimates approaching $400,000 per truck. Initially, that massive figure seems intimidating, but it accounts for not only increased material costs but also Tesla's advanced battery chemistry, tri-motor performance, and a unified charging system built to reduce downtime and service needs. Looking at that $415,000 number as just a sticker price fails to capture the full story. These trucks are designed to drastically lower operational expenses and generate savings across their entire operational lifespan. within Tesla's own internal planning documents now making the rounds online. We can see a mass production base price of $250,000 to $300,000. Once again, it's easy to compare that to the $150,000 and $180,000 promises from 2017. But keep in mind this new price point buys fleet's superior aerodynamics, on-the-go megacharger access, and features like electric power takeoff, which replaces auxiliary diesel units. In practical terms, you're buying a vehicle that pays for itself while it's on the job. Key to Tesla's argument is the total cost of ownership, or TCO. A Tesla Semi using 1.6 kilowatt-hours of electricity per mile, at an average electricity rate of 8.32 cents per kilowatt-hour, leads to a fuel cost of about 13.3 cents per mile. For comparison, a diesel truck now costs roughly 44.7 cents per mile to run. The gap between them is about 31.4 cents per mile, which adds up to approximately $314. Zero in savings over 1 million miles, add in a cautious 15% reduction in maintenance. For instance, 15 cents per mile versus 20 cents per mile for diesel, and you save another $7.500 annually for a medium-duty run, accelerating the payback. Picture a mid-sized carrier operating for 500-mile routes a day. Annual fuel expenses plummet from $67,000 on diesel to less than $20,000 with a Semi, saving over $45,000 every year, combined with simplified servicing and Tesla's over-the-air software updates. That purchase starts to feel like a strategic advantage instead of a financial liability. Even a 5.5-year payback on a $300,000 premium is well within typical 7-year truck replacement cycles, especially with electricity prices trending down. And to bring the Tesla Semi's optimized investment case to life, Tesla is concurrently building the charging infrastructure required to realize its long-term savings. On July 29, 2025, Tesla activated a dedicated megacharger bay at PepsiCo's Denver location, making sure Frito-Lay's pilot fleet can recharge swiftly between routes. In California, PepsiCo and Frito-Lay have gotten permits to install 8 additional semi-specific chargers at their Bakersfield facility, removing range concerns on busy corridors. Outside of corporate locations, Tesla is finishing its first public megacharger station at 1930 South Hamilton Avenue in Carson, which is strategically located near the Port of Long Beach to serve heavy freight routes. These customer and public-facing installations are only the start. At the ACT Expo in April, Tesla revealed a plan for a network of 46 megacharger sites across the U.S. by early 2027, establishing a continuous charging network that mirrors diesel refueling stations, with ultra-fast 1.2 megawatt charging posts at both private depots and public locations. Fleet managers can schedule predictable routes and cut down on idle time. When paired with the Semi's lower energy cost per mile and reduced maintenance, this growing infrastructure transforms a higher initial price into a smooth, cost-effective operation, turning sticker shock into a strategic edge. What are the 18 insane upgrades Tesla is creating for the Semi? The Tesla Semi has always left a strong impression with its powerful performance. But Tesla is obviously not finished. All existing semi-trucks are prototype models given to a select number of customers for testing and feedback before Tesla locks in the design and starts mass production at its new plant. Recent leaks indicate that the Tesla Semi is set for some significant design revisions, most notably to the headlights, suggesting the imminent launch of Tesla Semi version 2. We realize some of these updates might be controversial, but many customers will probably embrace them. To date, only about 500 units have been built, half were delivered to clients, while the other half are kept by Tesla for internal testing. One of the key reasons for the delay in mass production is the necessity of collecting real-world data from users. Tesla is seeking feedback from PepsiCo and its other early pilot partners over a minimum 2-year trial period before committing to the final production design of the truck. This testing phase not only allows Tesla to perfect the design but also acts as a vital chance to assess the Tesla Semi's performance in real-world operational scenarios. The information gathered from major clients like PepsiCo offers crucial insights into how the truck handles outside of controlled test environments. So, although the Tesla Semi was revealed several years ago, full-scale production has not started. Beckhouse Tesla is awaiting customer feedback before finalizing adjustments. It's logical that no one would be so careless as to mass-produce a vehicle that isn't fully refined. It would be plagued with problems. That's why, as the Semi's production plant nears completion and the trial period with logistics firms concludes, Tesla has unveiled multiple updates to the Semi from the initial prototype. We feel the revised design appears modern and fits well with Tesla's current design philosophy. We are optimistic that the new version will look like this because, in our opinion, the Semi is far more attractive with the LED light bar than with its existing headlight design. We are truly eager to find out more about Tesla Semi version 2. And it's more than just the headlights. Dan Priestley has stated that various other components will be updated as well. We suspect there are many more upgrades Tesla is developing that haven't been made public yet. What we have seen is merely the beginning, and it's apparent that Tesla is holding many improvements back. One key detail, though not officially confirmed, is that there are increasing indications that Tesla Semi Generation 2 could be launching shortly. Dan Priestley has revealed that Tesla intends to release a new electric truck variant with a sleeper cab, which would allow drivers to manage long-haul routes with more comfort. However, the debut of this version is contingent on the advancement of Tesla's new factory and the expansion of its megacharger network. This higher-end model will likely be assembled at the new plant, as Giga Nevada currently only has the capability to make prototype versions of the Tesla Semi right now. The Tesla Semi uses 2,170 battery cells with a total capacity of 900 kilowatt-hours. But a switch to a new battery technology is approaching. The new 4,680 battery cells are anticipated to replace the 2,170 cells that currently power the heavy-duty trucks. You may not be aware that the factory expansion in Nevada has been accelerated. According to sources, 2 new production plants will be constructed for the expansion, one for manufacturing 4,680 format battery cells with a 100 gigawatt-hours annual capacity, and another for the mass production of the Tesla semi-electric truck. It is difficult to believe that the Tesla Semi wouldn't ultimately use battery cells made at the same location, particularly since it would give Tesla major cost benefits. Furthermore, the Semi has already experienced significant delays waiting for the 4680 cells, which could be why only around 100 trucks were built between 2022 and 2023, according to Tesla. The supply of 4,680 cells is now growing, which could be excellent news for the electric truck initiative. Make no mistake, we are certain the Tesla Semi will move to 4,680 batteries soon, but it probably won't be an immediate switch. The trucks being assembled at Giga Nevada are still using 2,170 cells. If our analysis is right, once the dedicated Semi factory is finished and Generation 2 enters production, the trucks will feature 4,680 batteries. The 4,680 battery is a superior match for Class 8 trucks than the 2,170 cell, not only for its improved performance but also for its greater safety features, with an innovative design allowing for better thermal management. It disperses heat more efficiently and lowers the risk of thermal runaway, a hazardous event that can cause fires or explosions. If a battery overheats, the tabless deasing of the 4,680 battery not only lowers internal resistance but also improves thermal regulation, making it safer during high-performance use. Its larger form factor allows the 4,680 cells to be integrated directly into the vehicle's structure, enhancing both its sturdiness and crashworthiness. This is particularly vital for trucks like the Tesla Semi, where safety and performance are top priorities. With the 4,680 battery, the Tesla Semi not only gets more range but also offers greater confidence when it comes to safety, ready to handle the rigorous demands of future freight logistics. However, it's obvious that battery safety is not the only factor in an electric truck's overall safety. The driver's actions also play a huge part. In truth, even the riskiest lithium-ion batteries won't cause fires or explosions without some kind of impact. In a recent fire incident, while it remains unknown if the driver dozed off or lost control, it was clear something was absent from the Tesla Semi. That's correct. It was full self-driving capability. The positive news is that Tesla is actively working to integrate full self-driving into the Semi, as recent video footage has demonstrated. Tesla's Semi doesn't just appear futuristic, it's a showcase of aerodynamic design. Early models already had a remarkable drag coefficient of 0.36, over 30% less than a standard Class 8 diesel truck, which is around 0.5 to 0.6. That factor alone provides about 10% fuel savings at highway speeds. For the production version, Tesla has perfected every curve. Fully enclosed wheel covers prevent turbulent air around the tires. A flatter underbody stops airflow from separating under the chassis, and deployable side skirts close the gap between the tractor and trailer, reducing wake drag by as much as 20% compared to a truck with standard side panels. To give this context, conventional trucks with flat undersides can see their drag coefficient jump to 0.65 in crosswinds, meaning the semi moves through the air with almost half the drag, extending its range and lowering energy use in real-life scenarios. Beneath that aerodynamic exterior is a tri-motor powertrain combined with Tesla's newest battery chemistry innovations, keeping its three-motor design for powerful torque. The Semi's production model uses next-gen cells that provide a 7% efficiency improvement over the trial packs due to higher energy density and reduced internal resistance. In reality, the 300-mile and 500-mile models now use under 1.85 kilowatt-hours per mile, even fully loaded, which is similar to a light-duty EV. Meanwhile, diesel rivals consume 50 to 60 liters of fuel per 100 kilometers, roughly equal to 1.8 kilowatt-hours of energy use for every mile driven, at similar weights. Additionally, by lowering the total battery weight, Tesla makes the truck several hundred kilograms lighter, which further enhances payload capacity and driving dynamics inside the cab. Tesla redefines conventional design with a driver-focused cockpit. The seat is positioned in the center, providing balanced visibility down each side of the road and doing away with the skewed perspective of traditional left-hand driving. Dual 15-inch touchscreens are positioned on either side of the steering wheel, combining vehicle stats, navigation, and telematics into intuitive, adaptive displays. No more switching between different gauges and infotainment screens. A panoramic drop glass door on the passenger side opens for simple cargo inspections at stops, eliminating the need to climb down from and walk around the cab. The available heads-up display shows essential route information directly on the windshield, reducing glance-away time and aiming for a projected 15% decrease in driver fatigue on long journeys. Will Tesla's proposed network of 46 megacharger stations by 2027 truly accommodate long-haul trucking demands? Or is the company presenting an ideal infrastructure scenario that is still unattainable for the majority of transport fleets? Please give us your thoughts in the comment section below this video. Thank you for watching our video. If you'd like to see more fascinating content about Tesla EVs or the Tesla bot, please don't forget to press the like button and share this video. Also, be sure to subscribe to Juicy Tesla Car World and activate notifications so you won't miss our newest videos. We are grateful for your support and hope to see you in the next video. Goodbye.